Today we're going to continue with section 1.5, and our objectives today are we're going to identify midpoints of segments and identify bisectors and trisectors of both segments and angles. So we're going to look at some more vocabulary words. And our first vocab word is segment bisector. It's a point, segment, ray, or line that divides a segment into two congruent segments. All right, so to identify this or show what it means with a picture, I've got a segment. So remember, a segment starts at a point, ends at a point. So I'm going to call that segment AC. And then it can be anything, like it says. It can be a point, a segment, a ray, or a line that divides this segment. So I'll demonstrate it with a point. So a point, I'm going to call it B. Obviously, if it is dividing it into two, it's got to be in the middle. And remember, to indicate then that B is truly in the middle, we have to indicate with tick marks that we've got two congruent segments. So based off of this picture, I would say that the point B bisects the segment AC. Okay, I'm going to give you another picture. So say we have our segment, let's call it DF. And this time I'll show you that, once again, it doesn't just have to be a point, but it could be another segment, array, or a line. So here's a point. Let me say that we do a line this time. I'm going to call it line M. All right, and it's intersecting that segment at point E. And then once again, if it's the segment DF that's being bisected, I'm going to indicate it this time with two tick marks on either side. And this time, this indicates that it's line M that bisects the segment, and this segment would be segment DF. But I could have taken that line and I could have just made it an array, or I could have just made it a segment. So here are just two pictures out of the four potential types of things that could bisect a segment. A midpoint is the bisection point of the segment. Okay, so if I have a segment, I'm going to call that segment GI. A midpoint, notice how it has the word point in it, so it has to be a point. I'm going to call that point H, and because it's the bisection point, well, we just talked about what it meant to bisect a segment. It has to divide that segment into two. So like here is a different type of tick mark indicating that those two smaller segments, GH and HI, are congruent. So this time I would say that H is the midpoint, and I'm going to abbreviate midpoint like this. So there's my little abbreviation for the word midpoint. H is the midpoint of the segment GI. All right, notice that my note down here, super important. Angles will not have midpoints, only segments do. To trisect, we'll think of the word tri, like tricycle has three wheels, or triangle has three sides. So to trisect means that we're either dividing a segment or an angle into three congruent pieces. Okay, so let's take a segment. Let's call that segment AD. To trisect it means that I'm going to have two additional points. Let's call those points B and C. And notice now AB is a segment, BC is a segment, CD is a segment. Notice how I indicated with one tick mark on each of those smaller segments. This tells us that the points B and C trisect the segment AD. Okay, so we took one big segment and we cut it into three equal or congruent pieces. It can be the same thing with an angle. So let me indicate with a picture here. So here we have an angle. I'm going to call this angle EFG. Okay, and so then I'm going to have a couple of more rays shooting out of the vertex of that angle. I'm going to call this ray FH and ray FI. But notice that now that one big angle of EFG is broken into three smaller angles. And to indicate that those smaller angles are congruent, well, they have to all be marked the same. So notice that in this case, it's the ray FH and it's the ray FI that trisect the angle of EFG. Okay, so when it's a segment, it's points that trisect. Technically, I could have had segments that help trisect or anything along those lines. Here, when I'm talking angle, it's rays that trisect. An angle bisector. So a ray that divides an angle into two congruent angles. We've already talked about what it meant to bisect a segment. Well, now it's the same idea for talking about an angle. So let me sketch a picture. Here is an angle. I'm going to call this angle QST. All right, so I have to have another ray at that vertex of S. I'm going to call that the ray SR, and then here's my markings. They're the same markings, which indicates I have two smaller congruent angles. So in this, it's the ray SR that bisects the angle of QST. All right, so now let's take all of those and let's specifically talk about midpoints and segment bisectors and trisectors. So the question is, do rays or lines have midpoints? Okay, so notice that a ray, remember, a ray starts at a point and it just continues and it has an arrow because it goes on and on and on in one direction. So it's very hard to measure something that just keeps going and going and going. And so because it just keeps going and going and going because of that arrow, we cannot pinpoint an exact spot of where the middle would be to create that bisector. If I'm thinking about a line has two arrows because it keeps going and going and going in both directions. So once again, it's very hard if things keep going and going and going to find that exact middle. So my question was, do rays or lines have midpoints? My answer is no, because rays and lines extend infinitely. We cannot find the middle to divide these evenly. Okay, so that's why I only ever defined a segment as having a bisector or a midpoint. Okay, rays and lines, which extend, you can't find that exact middle, and so it cannot divide nicely. So here I have a picture. It says if the segment AB bisects the segment DE at point C, what conclusions can be drawn? Okay, so very clearly notice that we're bisecting the segment DE. So even though there's this other segment of AB, only the segment that comes after that vocabulary word is what's truly being bisected. So I'm going to mark it in my picture. If DE is the segment that's being bisected, that means that DC and CE, those are the two pieces that are congruent. Even though it might appear that AB has been broken into AC and BC correct, or like nicely, I cannot assume that. So what conclusions can be drawn? Not only is AB, that segment, bisecting, but I can say since it connects at point C, I can say one conclusion is that C is the midpoint of the segment DE. Because at point C in the middle, it's what's creating those two smaller congruent segments. And how I have it marked in the picture, since something is being bisected, well, bisect means to divide into two equal pieces, and I already marked it in my picture. I know that the segment DC is congruent to the segment CE. All right, but once again, there's nothing else that I can determine as far as that segment AB. Okay, I don't know anything about that having congruent pieces. So these are two good conclusions based off that information that's given. So in this next one, it says if the segment AB is congruent to the segment BC. So I'm going to mark it. So here are my markings indicating that those two are congruent. It says what conclusions can be drawn. Okay, so notice that because those are congruent, that means that B is the point in the middle of that segment. So I can say that B is the midpoint of the segment AC. I can also then say, notice that since point B is on that line of RS, I can say that the line RS bisects the segment AC. Okay, but because RS is a line, because there are arrows on either side here, I cannot indicate that B is in the middle of that line. And so there's nothing that I can conclude about that line. So really, those are two really good conclusions about that segment being congruent. Okay, that B is the midpoint of AC and that line is bisecting the segment AC. So here I'm given that Y is the midpoint of XZ. Nowhere in this problem does it have a diagram, so I'm actually going to sketch a picture of that given information. So the segment XZ, so XZ, it has that midpoint of Y. Well, a midpoint is in the middle, and that means that now I have two smaller segments that are congruent, XY and YZ. Notice that I'm also given that XY is represented as 3x plus 2. I'm going to write that right above in that segment. I know that XZ, this whole entire thing right here, that is a length of 20. It says they want us to find the value of X and then find the length of XY and YZ. Well, because I gave you that whole entire length of XZ, think about it. If Y is the midpoint, that means that it's halfway. So really, because I'm giving you the entire length, we can find the length of X, Y, and YZ with not really having to do much algebra. I'm just taking 20 and I'm dividing it in half. That tells me that those two smaller lengths of X, Y, and YZ, those both have to be a length of 10 because 10 and 10 get me that entire length of 20. So I just answered the second half of that question without really having to do too much algebra. But now going back to the first part, it says find the value of X. Well, notice that in this particular problem, if we know that 3x plus 2 represents that segment xy, but I also know that it's a length of 10. If those two things deal with the exact same segment, well, then I get to take those two things and I get to set them equal to each other. So 3x plus 2 is going to equal 10, and that's how I'll start solving for x. So I'm going to subtract 2 from both sides. That gives me 3x now equaling 8. And then I'm going to divide both sides by 3. And 8 divided by 3 is going to be a repeating decimal. And so I'm just going to leave it as a fraction. That fraction does not simplify any further. So x equals 8/3. Here's my next problem. It says the segment BC is divided by Z into the ratio 5:3 from the left to the right. So just like the last problem, I don't see a picture. So my first step is let's sketch a picture so we can visualize this. So they're giving me a segment, BC. And it says that Z is dividing up that segment into the ratio of 5:3. Now, because we are not given that we have a midpoint and the ratio one side is bigger than the other, Z cannot be located in the middle. Okay, from the left to the right. So that means since 5 is bigger on the left, I need to have a bigger segment on the left than I do on the right. Z then means that it has to be kind of closer to C than it is to B. So I'm going to put Z right there. Okay, when we're given a problem, we're talking about ratios. Those numbers, while they're not the actual length of the segments, they're going to help us create an expression for those segments. So the left side, if we look at my picture, is now really the segment of BZ. On the right side, that's really the segment of ZC. So really, I'm going to put an X at the end of each of those numbers in my ratio. And so BZ is really 5X and ZC is really 3X. It says BZ is 10. So I know that this length is 10. They want us to find the length of the segment ZC and then that entire length of BC. So very similar to the last problem that we just did, notice that 5x and 10 are represented by the exact same segment of BZ. And so when you have two things representing the exact same segments, well, my equation then is I get to set those two equal to each other. So 5x equals 10, divide by 5, and I know that x equals 2. That's going to help me find the length of the segment ZC because ZC is represented as 3x. So plug that value of x, which is 2, back in. 3 times 2 gives us our first answer. ZC is a length of 6. So now if I want to find the length of BC, notice BC is made up of both 5x as well as 3x. So I could add those two pieces together. 5x and 3x gives us 8x. And then I already know that x is 2. I could plug 2 in and I could get my answer. Another way is that now that I know that this is a length of 6, I could just add 10 and 6 together to get that entire length. But regardless of which method you use, 8 times 2 gets us 16, or 10 plus 6 gets us 16 as well. So there is my other answer. My next problem says we have the segment RS. It's divided by both points A and B into the ratio 2 to 3 to 7, going from the left to the right. Once again, I'm going to sketch a picture to help us out. So segment RS. It's got 2 points on that segment, A and B. But if I'm looking at how these numbers are broken up, notice that 2 is smaller than 3, which is smaller than 7. So I need to have a small segment first. So that's where I'm going to put the A. I need a little bit bigger of a segment. So B is going to have to be a little bit farther away from A. So notice that 2x, and then 3x, and then 7x. There are my segments going from left to right. And once again, whenever I have a ratio, I always put those x's at the end of those numbers. They tell us that RS, this whole entire segment, is a length of 40. They want us to find AB. So if I know what those three little ratios are individually, notice that adding them up together will get me the entire length of RS, and that is the number that I have. RS is 40. So I'm going to create my equation by adding those three ratio expressions up together and setting it equal to the amount that I'm given. So 2 plus 3 plus 7, well, that's going to give me 12. So 12x equals 40. I'm going to divide both sides by 12. And so when I divide, it's not going to be the nicest number. So I'm just going to reduce down this ratio. Both of those are divisible by not only 2, but 4 is the bigger of the numbers. 40 divided by 4 is 10, and 12 divided by 4 is 3. So there is the value of x. Now, that's not my final answer because the question says find the length of AB. So segment AB is represented as 3x. 3 times my value of x, which we just got to be 10/3. So 3 times 10/3, that gives us a length of 10. And that's my answer. Moving on to some angle problems. So it says we are given that this angle ABC, which if you look at it, that's the biggest angle in this picture. So the measure of angle ABC, this whole entire angle, is represented as 10x minus 24. We're told that the angle ABD, so if you follow the letters, that's this little angle right here. ABD is represented as 2x. I'm told that the ray BD is bisecting the angle ABC. Well, to bisect means that to divide it into two equal pieces. If I know that one of those small pieces is represented as 2x, that means that this angle over here is also 2x. So I don't have a specific number value like I did with some of those segments, but this time I have enough information to create an equation so I could start solving for x, which will then eventually allow me to find what I'm looking for. Because 2x and 2x, those two smaller angles form the big angle, I already know what the big angle represents. So that's going to be my equation. Take the two smaller angles and add them together. That is equivalent to the expression of the big angle. Well, 2x and 2x is 4x. And now I want to start solving for x. So I got to get x by itself, which means that I first have to combine them together. So I'm going to move all the x's over to the left. 4x minus 10x is negative 6x. Now that still equals negative 24. If I divide by negative 6, a negative divided by a negative will give me an x value to be positive, so positive 4. So if I want to find the measure of the angle ABC, I know what the expression is. It's 10x minus 24. So the measure of angle ABC is now me just plugging in 4 into the x. So 10 times 4 minus 24. 10 times 4 is 20. 20 minus 24 is going to get me the measure that I want. And so that's going to give us a 38, and we're talking angle, so degrees. So 38-degree angle is the measure of that angle ABC. Here's another angle problem. We're told that the angle XYZ, so if you follow the letters, it's the really big angle here, that is a measure of 61 degrees. We're told that angle 1, I'm going to write what that expression is inside by angle 1. So angle 1 right here is 2x plus 1. The expression for angle 2, which is this middle angle, is 3x. And angle 3, that's the expression of 8x minus 5. So I've marked everything in my picture based off of the given information. The question is, has the angle XYZ been trisected? So now remember, to trisect means to divide into 3 equal pieces. It's not something that I can assume. It's something that I'm trying to figure out if it's really a possibility. So because I don't know if anything's been trisected, the only information that I can really do to create an equation is take those 3 smaller angles, and if I add them all together, it gets me the measure of the big angle that was provided to us. So I'm going to add up all 3 of those small angles and set it equal to the measure of the really big angle. So now I want to start combining like terms so I can solve for x. 2x, 3x, and 8x. Well, 2 and 3 is 5, 5 and 8 is 13. So we'll have 13x. Notice that we've got a couple of numbers on the same side. 1 minus 5 is negative 4. This still equals 61. Got to start solving for x, so I'm going to add the 4 over to the other side. 13x now equals 65. I'm going to divide both sides by 13, and this is going to get me a value of x to be 5. Once I found that out, to determine if I have a trisected angle, well, that means I want to know what's the measure of angle 1, what's the measure of angle 2, and what's the measure of angle 3. Because if I know the measures of these and they're all the same, meaning that they're all congruent, well then yes, it's been trisected. So I'm going to substitute 5 back into each of those expressions. So we're going to have 2 times 5 plus 1. We're going to have 3 times 5. And we're going to have 8 times 5 minus 5. Well, 2 times 5 is 10. 10 plus 1. Here we have an 11-degree angle for the measure of angle 1. 3 times 5 is 15. So that's that measure. 8 times 5 is 40. 40 minus 5 is 35. So as you can see, those 3 angles are definitely not the same measure. So even though my picture might look like those angles are all the same and congruent. In reality, they aren't. And so because those are not the same measure, the question is, has this been trisected? And the answer is no. Here we want to use all four terms to describe the picture. So it says we've got non-collinear, angle bisector, ray, and congruent. All of these are vocab words that we've been talking about these last few sections. So we want to use all four terms to describe this picture. We can write one sentence, two sentences. We could write four sentences. It really doesn't matter. We just have to describe this picture. So non-collinear. If I start with that vocab word, remember, non-collinear means that we're dealing with points that do not fall on the same line. So if I'm looking at this picture, one statement can be that points A, B, and C are non-collinear. Because if I tried to connect all three of those points, they would not fall on the same line. So that takes care of that vocab word. If my next vocab word is angle bisector, well, to bisect an angle means that you're dividing it into two equal pieces. When you're talking about an angle, it's the ray that bisects it. So notice that the ray that's bisecting the angle is the ray BC. So actually, I'm going to be able to use this one statement, and I can maybe use all three of these words. So notice ray. So I can start off by saying that the ray BC, I can say that this is an angle bisector. To the angle ABD. Oops, not C, D. All right, so there we already used non-collinear, we just used ray, and we just used angle bisector. So now we only have to figure out how to describe congruence. Well, we can say that based off of this diagram, notice that there's two smaller angles marked the same. So I can say that the angle ABC is congruent to the angle CBD. And there are all four of my terms to describe that one picture. Here's an error analysis. So Jenny's unsure of her answer to a problem from a recent assignment. If we agree with her work, then we're going to explain how we know that her solution is correct. If we disagree with Jenny, then we're going to identify the mistake and then solve the problem correctly. So in the problem, it says that the segment EH is a length of 56. So notice that EH, if I was to mark it up, is this entire thing right here. So that whole thing is a length of 56. Notice how within the diagram, they've broken up that segment into three different pieces. And so one piece is 8x, one's 5x, and one is 2x. Notice the equation that Jenny set up is she added up all those pieces and she set it equal to 180. So hopefully you see that there is a mistake. I disagree with Jenny. Notice that her mistake comes from that number of 180. Remember, 180 a lot of the times is dealing with degrees when we're thinking about straight angles. This is not an angle problem. These are all segments. And so because 180 is talking about angles and we're dealing with segments, that's the issue here. So my disagreement with her, the mistake is that Jenny set the equation equal to 180 when really the length of the segment is 56. That's the given information. We were given that EH is 56, not 180. So I'm going to redo now the problem and solve it correctly. I liked that she added up all of those pieces because they formed that segment of EH, but we know that EH is really a length of 56 instead. So now I'm going to combine like terms, 8x, 5x, and 2x. I agree with her work there. 8 and 5 is 13, 13 and 2 is 15. So that is 15x, but it has to equal 56. And so now I'm going to divide both sides by 15 to get x by itself. Once again, this does not divide nicely. And so because it's a repeated decimal, I'm going to leave it as a fraction. This fraction does not reduce down any further. So I'm just going to leave it as 56 over 15. There is us solving for x. Okay, so that's us using midpoints of segments and then talking about bisectors and trisectors of segments and angles.